Hi, this is Sherman Bolaños and I'm here to discuss about dilation. Dilation is a transformation whose pre-image and image are equal. Thus, dilation is a similarity transformation. A dilation that creates a larger image is called enlargement, and the scale factor is greater than 1. A dilation that creates a smaller image is called a reduction, and the scale factor is between 0 and 1. So for this discussion, I will be showing you how to compute for the dilation of a pre-image and how to graph them as well. So let's begin. So for first given for enlargement, we have triangle ABC, where A's coordinates is -2 and 3, B's coordinate is -3 and 2, and C's coordinate is 1 and 3. So use scalar multiplication to find the image of triangle ABC for dilation at center of 0, 0 and a scale factor of 3. And then we'll draw the image. So we have here our Cartesian plane. So first we'll need to graph the coordinates of each point. So here's for our point A, which is -2 and 3. Point B, which is -3 and 2, and point C, which is 1 and 3. Let's connect them. We have the pre-image for these coordinates. So let's begin computing for the Alright, so for our first example in enlargement of dilation, we have here the triangle ABCs with the coordinates for point A, -2 and 3, point B with -3 and 2, and point C with 1 and 3. So for this given points, we have the scalar factor 3. So the first thing we'll need to do in solving for the scale of this dilation is to write this given coordinates in matrix form. So let's have here -2 and 3, -3 and 2, and then 1 and 3. So in writing matrices for coordinates, please keep in mind that the first row of the given or first row of the matrix will be our x coordinates and the second row of our matrix will be our y coordinates. Since we have the scalar factor 3, we'll write it outside our matrix, which signifies that we'll need to multiply this factor with all the given numbers within our matrix. So we have here -6, 9, -9, 6, 3, and 9. Now that we have the dilated form of our matrix, we'll now proceed in writing them back to their coordinate form. So for us to identify the differences of the dilated form of our coordinates, we'll use the prime symbol for our given points. So point A will be A prime, and then we'll have here -6 and 9. B prime, it will be -9 and 6. And then for C prime, we'll have here 3 and now. Now we have the coordinates for A prime, which is -6 and 9, B prime, which is -9 and 6, C prime, which is 3 and 9, and then let's connect them. As you can see, we have the similar image as our pre-image, just an enlarged version of it. Let's proceed. So for second example, we have enlargement quadrilateral CHUM, wherein point C has coordinates of -4 and 2, point H has -3 and -3, point U has 4 and 1, point M has 3 and 2. So for this, we'll use scalar multiplication to find the image of quadrilateral CHUM with a scale factor of 2, and then we'll draw the image. Okay, first let's draw the image for the given points. Now that we have this, let's connect the dots. And here we go. We now have the pre-image for our quadrilateral CHUM. Now let's compute for the enlargement version or the dilated version of this quadrilateral. Like what we did the first time, we will need to transform these coordinates into their matrix form. So let's have here -4 and 2, -3 and -3, and then we have 4 and 1, 3 and 2. Since we have the scale factor 2, let's put that outside of our matrix to signify it that it will be multiplied to every single number within the matrix. And then let's have that here. So 2 times -4 is -8, and then it will be 4, -6, -6. Here comes 8, 2, 6, and 4. Okay, let's check. 8, 4, -6, -6, -8, +8, 2, 6, 4. Now let's transform this to their respective coordinate forms. And please don't forget to put the prime sign just above the point. Alright, so going forward, we'll have here -8, 4. And then for H prime, we'll have -6 and -6. For U prime, we'll have here 8 and 2. For M prime, we have 3 and 2. Now that we have computed now that we have the respective coordinates for our dilated quadrilateral, let's draw them here on our Cartesian plane. So we have here the coordinates for C prime, which is -8 and 4, H prime, which is -6 and -6, U prime, which is 8 and 2, and N prime, which is 6 and 4. Let's connect them. Here we go. So as you can see, we still have the same pre-image, just an enlarged version of it. So technically, enlarging pre-images is somewhat like zooming into those images. So we still have the same shape, just on different size. So let's proceed with reduction. So for reduction, we have here triangle LUX, wherein point L has the coordinates of 4 and -6. Point U has the coordinates of -8 and 2. Point X has the coordinates of 10 and 8. So just like before, we'll be using scalar multiplication to find the image of the triangle LUX with a scale factor of 1/2. And then we'll draw the image. So let's have here the triangle LUX, wherein point L has 4, -6. Point U has -8 and 2. And point X has 10 and 8. So let's connect these coordinates. And now we have our pre-image. So now let's compute for the reduced version of this pre-image. So just like what we did with enlargement, we will first have to write these coordinates in matrix form. Okay, have here 4 and -6, -8 and 2, 10 and 8. And we have here the scale factor of 1/2. So let's put that outside our matrix. And let's solve. Okay, so we have here 2, -3, -4, 1, 5, and 4. So let's start in writing this new matrix into their respective coordinate form. So let's have here L prime, which is 2 and negative 3. By the way, don't forget that the first row stands for the coordinates x, and the second row stands for the coordinates y. So that's why we have here for L 2 and negative 3. Okay, so let's proceed. U prime, we have here negative 4 and 1. And for x prime, we have 5 and 4. Now that we have the value for the reducted image for this pre-image, let's now graph them in our Cartesian plane. So we now have L prime, which is 2 and negative 3. And then we have U prime, which is negative 4 and 1. And now we also have x prime, which has the coordinates of 5 and 4. Let's connect these coordinates. Here we go. So as you can see, we still have the same image as our pre-image, just a smaller version of it. Alright, so now let's proceed for our next example, which will be a quadrilateral. So for reduction of a quadrilateral, we have here the quadrilateral FLAN, wherein point F had the coordinates of negative 8 and 2, point L has the coordinates of negative 4 and 8, the coordinates of 6 and 6, and point N has the coordinates of 2 and 1. So just like before, we will be using the scalar multiplication to find the image of the quadrilateral FLAN with a scale factor of 3/4. But first, let's draw the image of our quadrilateral FLAN. So we have here the point F, which has the coordinates of negative 8 and 2. We have here point L with the coordinates of negative 4 and 8. Point A with the coordinates of 6 and 6. And point N with the coordinates of 2 and 1. So let's connect these coordinates so that we will have a visualization of our pre-image. And here we go. Now that we have our pre-image, let's now compute for the scale version or the scale of this quadrilateral with a scale factor of 3/4. Let's write this coordinate into their matrix form. So we've got negative 8 and 2, negative 4 and 8, 6 and 6, 2 and 1. Here we go. So now that we have these coordinates into their matrix form, let's have the scale factor just outside the matrix. So what we'll need to do now is multiply this scale factor with the rest of the numbers within the matrix. So 8 times 3 is 24. Divided by 4, it will be negative 6. 2 times 3 is equal 6. So the answer will be 6/4. It could be 3/2. Okay, so negative 4 times 3 is equals 12. Divided by 4 will be negative 3. 8 times 3 divided by 4 will be the same. So let's have the, no negative symbol. So that will be just 6. So 6 times 3 will be 18 divided by 4. We can write that down as 9/2. Since 6 is times 3 will be 18, and 18 and 4 are both divisible by 2. So let's have here 9/2. And then we'll have 6 as 2 times 3 will be 6 divided by 4. So it will be 6/4 or 3/2. And copy 3/4. Okay. So now we have our new coordinates for quadrilateral FLAN, and now let's write them down. So F prime will be -6 and 3/2. L prime will be -4 and 8. A prime will be 6 and 6. Oh, forgive me. So F prime should be -3 and 6. A prime will be 9/2 and 9/2. And N prime will be 3/2. Okay, 3/2 and 3/4. Let's just write this one much more clearly. 3/2, 3/4. Here. Now that we have the scaled coordinates of this point, let's now graph them in our Cartesian plane. So first we have the F prime, which is -6 and 3/2. Let's have it here. And then we have the L prime, which has the coordinates of -3 and 6. And then we have the A prime, which has the coordinates of 9/2. Okay, and 9/2. And then we have the coordinates of N prime, which will be 3/2 and 3/4. So let's connect these coordinates. And here we go. So now we have graphed the scaled version of our initial or the original quadrilateral FLAN. And now we have a new image or the scaled image of our pre-image. And that concludes the discussion for dilation today. Thank you very much and have a great day. Bye now.